Hi everyone, I'm here to talk to you today about loving science. I love science. Why do I love science? Well, it gives me an opportunity to explore the natural and the physical world around me and find out why things happen, to ask scientific questions and hopefully to explain things scientifically. The most fun things in science, I think, are things called discrepant events. A discrepant event is something that blows your mind, something you simply weren't expecting. How does it happen? This is where the science comes in. You can ask a series of questions and hopefully explain why these things happen. Today, our experiment is about heat transfer and heat capacity. So, who here's done a little cooking? Me. I bet you have as well. Whether it's as an older person, you might have a lot of experience cooking and you might just be new to science and getting a little bit curious. Or as a younger person, you might already love science, maybe haven't done so much cooking, but maybe you know a little bit about heat and heat transfer. What might happen, do you think, if I tried to cook my noodles at night in this? Putting it on the open oven or the open stove. This might melt, mightn't it? That's why I use an aluminium pot. Plastic simply won't cut it. It'll melt far too quickly. The aluminium pot will allow my foods to cook suitably. But what happens if I put this straight on the flame without anything inside of it? Well, it smokes out the whole kitchen. I've done that a lot. Why? We need water or oil, and that's got to do with heat transfer and heat capacity. Let's look at this thing a little bit more. In today's experiment, you're going to need a few things. I've got a dish over here with water. That's to extinguish any fires. I'm wearing my personal protective equipment, so I've got heat-proof gloves, I've got my goggles, my closed-in shoes, and I'm ready to go. I've got a candle here, some matches, some paper gloves, some water with a little food colouring in it, and some balloons. Have plenty of them on hand. Your first experiment may not work out, and that's okay. Mine didn't either. That's what experiments are all about. Okay, so let's light our candle and get a little flame happening here. And let's start asking some questions. Okay, what do you think might happen if I put this paper cup over the flame? You might think, of course I know what happens. It'll catch a light. How long does it take? 1 second, 2 seconds, 3 seconds, starting to smoke, 4 seconds, 5 seconds, 6 seconds, 7 seconds, it's on fire. Okay. This has a little residual plastic on it, so it takes longer than maybe you would find a normal paper cup. Okay. And they're the best I could find, and that's okay too. So let's look at what happens when you add a little water to this cup. Putting it on here, 1 second. 2 seconds, 3 seconds, 4 seconds, no smoke, 5 seconds, 6 seconds, no, it hasn't burned through. In fact, there's only a tiny little black spot. It didn't even begin to burn. So what did the water inside the cup do? Let's talk about that later. I'll let you start to think about those questions in your head while we're going. The next part of our experiment is going to be what happens when we hold this empty plastic balloon over the flame. I think you know what's going to happen. Wish me luck, okay? So here we go again. Good reason for our safety glasses. How long is it going to last, do you think? 1 second? 3 seconds? 10 seconds? I think you know the answer as well. Oh! So there we go. It's very fast. It doesn't have a very high heat capacity, and it's very rapid. Put my flame out. I think that was my screaming rather than actually the air coming out of the balloon. Okay, let's start again. What's going to happen when we do the same thing with a balloon that we've now filled with water? We put red food colouring in, and you can actually see the water inside. So, do you think this is going to burst as quickly? Okay, so we'll hold it over. A little bit scared because of last time, but we're ready. So we're holding it over the flame. 1 second, 2 seconds, 3 seconds. Look what's under here. A little black patch. Did it burn? No. Obviously, the presence of the water inside the balloon has done something. The same thing that it did when it was present inside the cup. What's the reason? Well, this might have been an event that you didn't expect. The reason is because water has a high heat capacity. That means that it takes a long time to heat up, and it takes a long time to cool down. Whereas paper and plastic have a lower heat capacity. Plastic, as you can see, is very low heat capacity at this density of plastic, so it just bursts straight away. So I hope you've really enjoyed this event. There's a series of questions that you can ask, and here's a little geeky fact for you. I love these little nerd facts. A balloon with 25 grams of water filled with 1 litre of air is 100 times more heat resistant, or has 100 times more heat capacity than a balloon filled with only 1 litre of air and no fluid. That's massive. And here's for you to ask why. I hope you enjoyed today's experiment, and I hope this helps you ask a few questions of your own. Enjoy science.